So let's compare the difference between revision 1.0.0 to revision 1.1.0. I made a couple of mistakes in this design, and I would like to fix them in second revision. So if we just first check on some aesthetic side, we can see that most of them nothing is changed. LED diode is moved a bit closer to the ESP32, and that's basically it. And one more point from the back side. Now we have some explanation on which pin are we using. So I think this is very useful information, because now you don't have every time to open the PCB schematic in order to figure out which pin you are connecting. In addition to that, I added a couple of power pins, so you now have the pin for 3.3 volts, ground, 5 and ground. And in addition to that, I created a cutout in PCB for antenna of ESP32. I made the choice to create a cutout, not to move this ESP32 a bit to the top, in order for PCB antenna to be free, because I didn't want to extend this PCB design. And if I just move this to the top, then I would like to have some more space, to reduce space from the bottom, and that meant a lot of reorganizing here, so I didn't want to do that in this revision. So just in order to free antenna, I just do something like this. In my testing, I didn't get any problems with PCB antenna, so yeah, I think that was just for some cosmetic and maybe functional purposes, but for my testing, this worked fine. I think that this can maybe increase the range, but for some indoor uses, I think this is fine. Next, if we open two PCBs side by side, we can see the difference, and the major difference is actually in connecting data pin for fully addressable RGB LED. In previous version, we have connection to pin 24, and in that pin, and that was the mistake, because this pin wasn't fast enough to carry over the communication part. So in my other video, which I would link now, I did some dirty fix where I basically break or drop this line up and create with a jumper cable connection between this data line and my data in for LED RGB. Of course, in the new revision, I like to fix that, but let me first just disable silk screen in order to be visible more. What I did is basically, now if we highlight the selected pin, I'm now routing this signal line onto PCB, and of course we just removed this connection from the data set, from the data input of the LED, and routing that to the outside for some future use. In addition to this, in PCB view, we can notice that now we have our 3.3 volts data line routed to this pin. We have a couple of ground pins that are routed to here and here, and of course we have our 5 volts that are coming from USB Type-C. And I move this LED RGB a bit more up, and I think for the revision, for the first revision, I think this should be enough. So we should be able to fix everything that was needed, and that's it. Of course, we here can see our cutout, and now if we just enable silk screens and maybe disable our gaps, we can see that now we have our enumeration of the pinout, which wasn't included in this revision. So I think with this and with this 3D views now, this is much more usable development board, especially with this. And I think now we can focus with the knowledge that we that we gain by doing this, we can focus on our next development board, which will be updated from S2 to S3 and from 2-layer board to 4 layers. In addition to that, I would like to add some battery management chip in order to have battery control, and maybe add on the bottom side additional connector for battery itself. So you have basically complete development board for your remote IoT projects. That is the plan, so stay tuned and see you in the next one.